For 70 years, we got it wrong. Open any astronomy textbook printed in the last half-century, look at any diagram in a classroom, or recall any documentary you have ever watched about our cosmic home. They all cite the same clean, comfortable number. They tell you the Milky Way is a spiral disk, approximately 100,000 light-years across. It is a number that has been drilled into the collective consciousness of our species, a boundary line that defined the scale of our existence. We thought we knew the size of our cage. We thought we had mapped the extent of our island in the dark. But here is what will blow your mind. That number is not just slightly off, it is a fundamental underestimation of reality. The Milky Way is not 100,000 light-years wide. New data suggests the true diameter of the galaxy's stellar structure extends nearly 2 million light-years into the void. We have been living inside a titan twice the size, 10 times the volume, and infinitely more complex than the models predicted. This isn't just a statistical correction. It changes the calculation of our galaxy's mass. It rewrites the history of how we formed, and it drastically alters the timeline of our eventual collision with Andromeda. If you want to understand the terrifying true scale of the galactic empire we call home, hit that like button and subscribe. We are rewriting the map of the universe. Prepare yourselves. Let's begin. We must first dismantle the image you hold in your head. When you close your eyes and picture the Milky Way, you likely imagine a flat, luminous phonograph record glowing in the dark. You see a dense, bright core, beautiful spiraling arms wrapped tight, and then a sudden fade into the blackness of intergalactic space. That is the classic galaxy. It is the model we built based on the limited light that reached our primitive telescopes in the 20th century. It was a neat, tidy definition. It gave us a sense of containment. We told ourselves that the stars ended where the bright spiral arms faded away. We defined the edge of the galaxy based on the limits of human vision, rather than the limits of physical reality. It was an arrogant assumption. We assumed that if we couldn't see it, it wasn't there. For decades, the figure of 100,000 light-years was treated as a constant, almost like the speed of light or the gravitational constant. It became the yardstick by which we measured everything else in the local universe. If a neighboring dwarf galaxy was 200,000 light-years away, we said it was 2 Milky Ways away. We built our entire sense of cosmic scale around this single metric, but the universe does not care about our textbooks. While we were busy congratulating ourselves on mapping our home, the galaxy was laughing at us. The reality is that the visible spiral disk, that beautiful glowing pinwheel you see in artist illustrations, is merely the downtown district of a sprawling metropolis that extends far into the suburbs. The discrepancy lies in how you define a galaxy. If you define it only by the bright, young stars clustering in the spiral arms, then yes, the old numbers hold some weight. But a galaxy is not just its brightest lights. It is a gravitational sovereign state. It includes every star, every cluster, and every wisp of gas bound to its center. Recent deep sky surveys have detected stars belonging to the Milky Way, gravitally bound to us, orbiting our center, out to distances that are frankly disturbing. We are finding RR Lyrae stars, pulsating ancient beacons, nearly 1 million light-years from the galactic core. Since the radius is the distance from the center to the edge, the diameter, the full width of the structure, is double that. 2 million light-years. Let the weight of that number settle in your mind. Light traveling at 186,000 miles per second takes 2 million years to cross the structure we live in. When the light from a star on the far edge of the Milky Way began its journey to the opposite side, humans did not exist. Homo erectus was just beginning to stand tall on the savannas of Africa. That light has been traveling through us, through our galaxy, for the entirety of human history, prehistory, and evolution, and it is only just arriving. The sheer volume of space this encompasses is impossible to intuitively grasp. By expanding the diameter from 100,000 to nearly 2,000,000 light years, we aren't just making the line longer. We are expanding the sphere of influence volumetrically. The body of the Milky Way is colossal beyond our previous comprehension. This shattering of the 100,000 light-year paradigm forces us to confront a new reality. The galaxy has no hard edge. There is no "Welcome to the Milky Way" sign. There is no cliff where the stars stop and the void begins. Instead, the galaxy fades. It diffuses. It stretches out into a vast, ghostly halo of stellar debris and ancient suns that patrol the outer rim like lonely sentinels. We have been looking at the bright city lights of the disk and ignoring the massive countryside that surrounds it. This stellar halo is the true footprint of our galaxy, and it is populated by the oldest stars in the universe, witnesses to the chaotic formation of the structure itself. Why does this matter to you, standing on a small rock orbiting a yellow dwarf star? Because it changes our status in the local cosmos. We used to think of the Milky Way and Andromeda as two separate islands separated by a vast ocean of nothingness. We believed we were isolated, safe in our own patch of dark. But if the Milky Way is 2 million light years wide and Andromeda is even larger, the gap between us shrinks dramatically. The empty space between these two giants is vanishing before our eyes. We are not two lonely islands. We are two giants reaching out to touch hands in the dark. The implications for the gravitational dance of the local group are profound. We are heavier, larger, and more dominant than we dared to calculate. This discovery also highlights a psychological blind spot in scientific inquiry. We prefer sharp boundaries. We like things to be binary, inside the galaxy or outside the galaxy. But nature operates on gradients. The atmosphere of Earth doesn't just end at 100 kilometers. It thins out until it becomes indistinguishable from space. The Milky Way does the same. We are living in a structure that is more like a fog than a solid object. The density drops, but the presence remains. We are finding that the void surrounding our galaxy is not a void at all. It is filled with the wreckage of cannibalized dwarf galaxies, streams of stripped stars, and the faint glow of the halo. The universe we live in today is not the universe we lived in yesterday. The coordinates haven't changed, but the map has expanded. We have gone from living in a modest house to realizing we are squatting in a palace. But acknowledging this size raises an immediate, frustrating question. If the Milky Way is truly this massive, if it spans this incomprehensible distance, why did it take us until the 2020s to figure it out? We have had telescopes for 400 years. We have had space observatories for decades. How could we possibly miss something that is literally right in front of our faces? How do you lose 1 million light years of real estate? The answer lies in the unique tragedy of our perspective. We are trying to read the label on the bottle from inside the bottle. The fundamental tragedy of galactic astronomy is that we do not have the privilege of a mirror. We can point our telescopes at Andromeda 30 million light years away and capture its majesty in a single, breathtaking exposure. We can trace its spiral arms, measure its bulge, and define its boundaries with exquisite precision, because we are looking at it from the outside. We have a front row seat to its grandeur, but for our own home, we are trapped in the cheap seats. Worse, we are trapped backstage, buried behind the scenery. We are attempting to map a forest while chained to a single tree in the middle of the thicket, surrounded by fog. Every image you have ever seen of the full Milky Way, every spiral wallpaper, every textbook diagram, every computer simulation is a lie. It is an artist's impression, a best guess reconstruction based on data points, or a photograph of a different galaxy, like NGC 6744, acting as a stunt double. No human eye and no human camera has ever seen the Milky Way. To understand why we got the size so wrong for so long, you have to understand the optical prison of our position. The solar system is embedded deep within the Orion Spur, sandwiched into the galactic disk. When we look up, we don't see a spiral face-on. We see a band of light splashing across the night sky, a cross-section of the disk seen edge-on. This is the Milky Road that the Greeks named Galaxias Kyklos. While beautiful, this perspective is scientifically disastrous. Imagine trying to determine the shape and size of your own city, but you are only allowed to stand in the middle of Times Square. You cannot ascend to a high vantage point, and you cannot leave the street level. You would see the buildings immediately around you, but the sprawling suburbs, the distant bridges, and the city limits would be invisible, blocked by the skyscrapers in your foreground. In the galaxy, the stars in the foreground block the stars in the background, creating a chaotic mess of overlapping light that makes depth perception nearly impossible without advanced mathematics. But geometry is not the only enemy. If space were truly transparent, we could simply count the stars in every direction and build a map. But space is not empty. The galactic disk is filled with the interstellar medium, vast clouds of gas and, more critically, cosmic dust. To the uninitiated, dust sounds trivial, like the lint you sweep from under your sofa. In astrophysics, dust is a catastrophe. It consists of microscopic particles of silicates, carbon, and ice that drift between the stars. While a single grain is irrelevant, a cloud of them spanning light years acts like a thick smokescreen. This dust absorbs and scatters visible light, particularly the blue wavelengths, acting as a relentless filter that dims everything behind it. This phenomenon is known as interstellar extinction, and it has blinded us for centuries. There are regions of our galaxy so choked with dust that they appear as black holes in the sky to the naked eye. The Great Rift, a dark band that splits the Milky Way in the night sky of the southern hemisphere, is not a lack of stars. It is a wall of dust blocking the blazing light of the galactic center. For generations, astronomers looked into these dark patches and assumed there was nothing there. They saw the darkness and interpreted it as the edge of the universe. They were wrong. Behind those curtains of soot lay billions of stars, massive clusters, and indeed, the vast extensions of the galaxy that we are only now beginning to uncover. We were looking at a wall of fog and mistaking it for the wall of the room. This obstruction created one of the most infamous blind spots in science, the zone of avoidance. This is a band of the sky covering about 20% of the celestial sphere, corresponding to the galactic plane, where our own galaxy is so thick with dust and stars that it blocks our view of the universe beyond. For decades, cosmologists had to accept that 1/5 of the extragalactic universe was simply off-limits to visible light astronomy. We couldn't see what was behind the core. We couldn't see the far side of the disk. We were mapping the Milky Way like a cartographer trying to draw the Earth while refusing to acknowledge the existence of the Pacific Ocean. We assumed the galaxy was smaller because the light from the distant edges was being extinguished before it could reach our telescopes. We were victims of reddening, where dust makes distant stars look fainter and redder, mimicking the appearance of closer, dimmer dwarf stars. This corrupted our distance ladders. We miscalculated the luminosity of objects, and therefore we miscalculated their distance. The structural complexity of the galaxy further camouflaged its true scale. We now know that the Milky Way does not just fade out smoothly. It has structure, warps, and flares that complicate any attempt to measure a simple diameter. But from our vantage point inside the disk, these features are incredibly difficult to disentangle. We are riding a carousel, trying to measure the speed and position of the other horses, while the carousel is spinning, and we are spinning, and the air is filled with smoke. When early astronomers like Jacobus Kapteyn in the early 20th century tried to map the stellar system, they concluded the Sun was near the center of a small, lens-shaped universe. They were deceived by the dust. It created the illusion of a central position because the light died out equally in all directions. It was a solipsistic trap. It took the genius of later astronomers to realize that we were viewing a filtered reality, seeing only the local bubble of clarity in a much vast, murkier ocean. Even as radio astronomy and infrared telescopes began to pierce the dust in the latter half of the 20th century, revealing the hidden heart of the galaxy, the outer limits remained elusive. The stellar halo, that ghostly sphere where the galaxy extends to its true 2 million light-year limit, is incredibly faint. The density of stars out there is pitifully low compared to the disk. Spotting a lone star at 800,000 light-years and correctly identifying it as part of the Milky Way, rather than a background object in intergalactic space, requires a level of precision that simply did not exist. We were looking for candles flickering on a mountaintop while standing next to a searchlight. The glare of the local disk drowned out the whispers of the halo. So we settled. We accepted the 100,000 light-year figure because it was what we could see. It was the effective diameter of the bright disk. It was a safe, conservative estimate that fit the data available. We taught it in schools because it was a clean number, easy to memorize, and consistent with the visible evidence. But science is the process of becoming less wrong. We were stuck in a deadlock, limited by our perspective and blinded by the medium itself. To break this deadlock, to finally see the true face of the Leviathan we inhabit, we didn't just need bigger telescopes. We didn't just need to look harder. We needed to look differently. We needed a way to strip away the illusion of 2D space and construct a true 3-dimensional model of the galaxy, star by star. We needed to stop guessing distances and start measuring them with mathematical absolutism. We needed a mapmaker capable of scanning billions of objects simultaneously, triangulating their positions with the accuracy of a coin on the moon. The solution wasn't on the ground. It had to come from above. The era of guessing ended on December 19th, 2013. That was the day the European Space Agency launched a time machine and a cartographer wrapped into one glittering sun-shielded package, the Gaia Space Observatory. Before Gaia, our understanding of the Milky Way structure was built on inference and local extrapolation. We had precise distances for only a handful of stars in our immediate solar neighborhood, the cosmic equivalent of knowing the layout of your own driveway, but guessing the geography of the rest of the continent. We needed a God's eye view, but we were stuck on Earth, So we built a machine to simulate godhood. Gaia is not a telescope in the traditional sense. It is the ultimate astrometric surveyor. Its mission was terrifyingly ambitious: to chart a three-dimensional map of over 1 billion stars in the Milky Way with unprecedented precision. And precision is an understatement. To understand what Gaia does, imagine standing in London and trying to spot a euro coin lying flat on the moon. Now, imagine trying to measure the thickness of that coin from Earth. That is the level of angular resolution Gaia operates with. It scans the sky repeatedly, spinning slowly, logging the position of every speck of light it detects over and over again for years. The magic lies in the method, parallax. It is the gold standard of cosmic distance measurement, the only method that relies on pure geometry rather than assumptions about stellar brightness. Hold your finger out at arm's length, close one eye, then the other. Your finger seems to jump against the background. That is parallax. Now, scale that up to the solar system. As Earth orbits the Sun, our position in space shifts by 186 million miles every 6 months. Gaia uses this baseline to see how stars jump against the background of more distant galaxies. By measuring that tiny shift, we can calculate the distance to a star with absolute trigonometric certainty. No guessing, no standard candles, just cold, hard math. But Gaia didn't just tell us where the stars are, it told us where they are going. This is the proper motion, the speed and direction of a star as it travels through the galaxy. By combining position and velocity, Gaia gave astronomers something they had never possessed: a 6-dimensional phase space map. For the first time, the Milky Way wasn't a static painting. It was a living, breathing organism. We could rewind time to see where stars came from and fast forward to see where they are going. We could disentangle the mess. We could distinguish a star that is actually part of the galactic disk from a star that is merely passing through, or a star that belongs to the distant halo. This data dump was a deluge. When the Gaia data releases, DR2 and DR3, hit the scientific community, they didn't just provide answers. They broke the servers. Astronomers were suddenly drowning in petabytes of perfect data. It allowed us to peer through the gaps in the dust. It allowed us to identify specific classes of stars, like the pulsating RR Lyrae variables, ancient stars that dim and brighten with a specific rhythm. These stars are crucial because they act as standard wattage light bulbs. If you know how bright they truly are, and you measure how dim they look, you know exactly how far away they are. Gaia identified these sentinel stars out in the darkness, far beyond where the spiral arms fade. It spotted them in the emptiness, marching to the beat of the galaxy's gravity, bound to us, yet located at distances that made no sense in the old model. The machine didn't care about our 100,000 light-year preconceptions. It simply reported the coordinates. It drew a line in the sand that was 10 times further out than we expected. The map was no longer a sketch, it was a blueprint. And the blueprint revealed that the walls of our house were miles away from where we thought they were. We had the tool. Now we had to accept the terrifying measurement it returned. The data returned by Gaia did not merely suggest a revision. It demanded a total rewriting of the galactic map. As astronomers sifted through the positions of millions of celestial objects, filtering out the noise of the background universe, they began to notice a population of stars that defied the traditional boundaries of the Milky Way. These were not the bright, young, hot blue stars of the spiral arms, born recently from gas clouds in the disk. These were the ancients. They were RR Lyrae stars, old, pulsating variables that have witnessed the entire history of the galaxy, and they were located in places that, according to our old maps, should have been empty void. In early 2023 and continuing into 2024, a team of researchers, including astronomers from the University of California, Santa Cruz, utilized this data to trace the outer limits of our galactic halo. What they found was a collection of these pulsating sentinel stars, stretching out to distances that seem mathematically impossible. They identified stars belonging to the Milky Way that were located over 1 million light-years from the galactic center. To be clear, we are not talking about a few stragglers that got kicked out by a black hole. We are talking about a structural component of the galaxy, a vast, diffuse, spherical halo of stars that bounds the system. If the radius is 1 million light-years, the diameter is 2 million. This is the number that changes everything, 1.9 million light-years to be precise. To understand the magnitude of this, you have to realize that for 70 years, we taught that the Milky Way was roughly 100,000 light-years across. We are now looking at a structure 20 times wider than the visible disk we see in pictures. This redefinition forces us to confront a difficult question. What is a galaxy? If you define a galaxy only by the concentration of light that shows up in a backyard telescope, then the old numbers are fine. That is the optical galaxy. But physically, a galaxy is defined by gravity. It ends where its gravitational dominance yields to the ambient pull of the surrounding universe. The stars found by these recent surveys are undeniably ours. They are chemically linked to us. They are gravitationally bound to us. They are the citizens of the Milky Way living in the furthest frontiers of the empire. These distant RR Lyrae stars act as the marker buoys of our true coastline. They are fascinating objects in their own right. They expand and contract in a rhythmic cycle, changing their brightness with clockwork precision. Because physics dictates exactly how bright they should be based on their pulsation period, if we measure how faint they appear to us, we can calculate their distance with pinpoint accuracy. They are standard candles burning in the abyss. By plotting the location of over 200 of these distant sentinels, scientists were able to trace the curve of the galaxy's outer edge. They found that the density of stars doesn't just cut off. It follows a predictable decline that extends out to this shocking 1 million light-year radius. Imagine the view from one of these outer stars. If you were standing on a planet orbiting an RR Lyrae star at the edge of the halo, the Milky Way would not look like a band of milk across the sky. It would look like a distant, swirling island of light, a terrifyingly beautiful spiral suspended in the black, occupying only a small portion of your sky. You would be so far away that the individual stars of the disk would blur into a single glowing fog. You would be in the deepest solitude imaginable, separated from the bustling stellar metropolis by a million light-years of silence. Yet, you would still be in the Milky Way. You would still be orbiting the center, held by the same gravity that holds the Earth to the Sun. This expansion of our borders creates a claustrophobic realization about our place in the local group. The most famous fact in intergalactic astronomy is that the Andromeda galaxy, M31, is our nearest major neighbor, located about 2.5 million light-years away. For decades, we visualize this as two frisbees floating miles apart in a large room. But if the Milky Way extends 1 million light-years in Andromeda's direction, and Andromeda, which is physically larger than us, extends even further in our direction, the math changes instantly. 1 million plus 1 million equals 2 million. The gap between the galaxies is 2.5 million. Do the math. There is practically no empty space between us. The halos of the Milky Way and Andromeda are likely already touching. We are not two separate islands. We are two atmospheric systems that have begun to merge. The gas and the faint stars of our outer halos are already mingling, shaking hands across the void. The collision that we have always said is 4 billion years in the future has, in a very real structural sense, already begun at the fringes. We are effectively living in a binary galaxy system, connected by a bridge of stellar debris and dark matter that we are only just now learning to see. This discovery also recontextualizes the empty space surrounding our galaxy. We used to think of the halo as a clean, empty region. Now we know it is a graveyard and a museum. This massive 2 million light-year sphere is populated not just by these lonely stars, but by the shredded remains of dwarf galaxies that the Milky Way has cannibalized over eons. The size of our galaxy is a testament to its violence. You don't get to be 2 million light-years wide by being peaceful. You grow that large by eating your neighbors. The stars we are finding out there are the debris fields of galactic collisions, the crumbs left over from a 10 billion year feast. The visible disk, the flat spiral part where the sun lives, is just the dense, gas-rich factory where new stars are made. But the halo is the archive. It is the vast, spherical scaffolding that holds the history of our formation. By pushing the boundary out to nearly 2 million light-years, we are finally acknowledging the full architecture of our home. We are acknowledging that the void is not void. It is structure. It is territory. However, this raises a physical problem that borders on the impossible. A structure of this size, composed of such widely scattered stars, implies a mass and a gravitational grip that defies the visible inventory of the universe. If you add up the mass of all the stars in the disk, and all the gas, and all the dust, and all these new RR-layery stars in the halo, the total gravity is pitifully insufficient to hold on to stars 1 million light-years away. These outer sentinels are moving too fast. They should have flown off into the intergalactic void billions of years ago. The centrifugal force of their orbits should have overcome the weak gravity of the luminous galaxy. But they didn't. They are still here. They are being held in place by an invisible hand, a grip so powerful it spans millions of light years, yet so subtle it casts no shadow. The sheer size of this new Milky Way is the strongest evidence we have ever found for the existence of the ghost that haunts our reality. To understand what holds this 2 million light-year behemoth together, we have to stop looking at the light and start looking at the darkness. We have to talk about the cage. The existence of a galaxy spanning nearly 2 million light-years presents a crisis for classical physics. If you were to take all the visible matter in the Milky Way, every shining star, every glowing nebula, every cloud of hydrogen gas, and even the supermassive black hole at the center, and put it on a cosmic scale, you would come up drastically short. Based on the amount of light our galaxy emits, the mass of the Milky Way should be roughly 10% of what is required to keep those distant stars in orbit. By all rights, the outer rim of our galaxy should not exist. Those ancient sentinels we discovered in the deep void are moving at velocities that should fling them out into the intergalactic abyss. The centrifugal force of their orbits vastly overpowers the gravitational pull of the visible matter. The galaxy is spinning too fast to hold itself together. It should have torn itself apart billions of years ago, scattering our sun and every other star into the lonely dark. The fact that we are here, spiraling intact, is proof that the visible galaxy is nothing more than a decoration. It is the paint on a much larger, invisible structure. We are living inside a ghost. This is the tyranny of the dark matter halo. When we look at the Milky Way, we are making the mistake of judging an iceberg by its tip. We see the spiral arms, the bright bulge, and the dust lanes, and we say, that is the galaxy. But that is incorrect. That is merely the luminous galaxy. The true Milky Way is a colossal spherical container of invisible matter, a halo that extends far beyond the furthest stars we have mapped. This halo is not a thin mist. It is the dominant component of our reality. It constitutes approximately 85% to 90% of the galaxy's total mass. The stars, the planets, the gas, you, me, and everything we have ever seen or touched are merely the impurities trapped in the center of this massive dark sphere. We are the glowing sediment that has settled at the bottom of a gravitational well, dug by a giant we cannot see. The scale of this dark halo is what allows the physical diameter of the galaxy to be so immense. The reason we can find stars 2 million light-years out is that the dark matter halo extends that far, and likely even further. It acts as the invisible scaffolding of the universe. Without it, the house of the Milky Way would collapse. This dark matter interacts with nothing. It does not reflect light, it does not absorb light, and it does not emit light. It ignores the electromagnetic force entirely. It has only one property that we can detect: mass. It is heavy. It warps space-time. It creates the gravity necessary to herd the stars into their spirals and keep the ultra-distant wanderers tethered to the system. Imagine looking at a distant mountain range at night. You can see the lights of a few cabins flickering on the slopes. If you only looked at the lights, you might think they were floating in the air, disconnected, hovering by magic. But you know that gravity demands they be supported by something. You deduce the existence of the mountain, the massive, dark, solid rock, because the lights are stationary. The stars of the Milky Way are those cabin lights. The dark matter halo is the mountain. It is the unseen bulk that gives the galaxy its shape and its stability. We are not a spiral galaxy that happens to have some dark matter. We are a dark matter galaxy that happens to have some stars in the middle. This reframing completely changes the history of our origins. For a long time, we thought the gas collapsed to form stars, and the gravity of the stars held the galaxy together. But the timeline is wrong. The dark matter came first. In the early universe, just after the Big Bang, dark matter began to clump together, forming vast, invisible wells in the fabric of space. It created the gravitational potholes. Normal matter, hydrogen and helium gas, was then pulled into these potholes, flowing down the gravity slopes until it concentrated enough to ignite into stars. The Milky Way was not built, it was poured. The structure we see today is the result of baryonic matter, us, surrendering to the overwhelming gravity of the dark halo. We are the afterthought. We are the glowing moss growing on a dark rock. Current estimates place the mass of this dark beast at roughly 1.5 trillion solar masses. But the distribution of this mass is what is truly unsettling. In the solar system, 91.8% of the mass is in the center, the Sun. So planets move slower the further out they get. Mercury zooms, Pluto crawls. This is Keplerian motion. But because the dark matter halo is a sphere that envelops the entire galaxy, the mass is not concentrated solely in the center. It is everywhere. As you move outward from the galactic core, you don't leave the mass behind. You encompass more of it. This means the gravity pulling on you stays constant, or even increases relative to your distance. This is why the outer stars orbit at breakneck speeds. They are feeling the cumulative grip of 1 trillion suns worth of invisible matter surrounding them. This halo concept also corrects our geometric bias. We are obsessed with the disk shape because that is where the light is. We think of the galaxy as a frisbee, but the dark matter halo is not a frisbee. It is a beach ball. It is a 3-dimensional sphere. The flat, spinning disk of stars where Earth resides is just a thin slice cutting through the equator of this invisible sphere. We are living on a dinner plate suspended in the middle of a vast, dark aquarium. This spherical nature is crucial because it dictates the fate of everything that approaches us. Any dwarf galaxy or gas cloud that wanders within 2 million light-years doesn't just pass by a flat disk. It enters the spherical atmosphere of the dark matter halo. It gets caught in the web. It begins to drag, to slow down, to be stripped apart by the tidal forces of this invisible monster. The implications for the edge of the galaxy are profound. If the dark matter halo tapers off gradually, then the boundary of the Milky Way is not a line, but a transition zone where the gravity of our halo finally loses the tug-of-war against the expansion of the universe, or the gravity of Andromeda. This territory is vast. It means that when we look into the empty space between galaxies, we are looking at the invisible bodies of the galaxies themselves. The skeletons are touching. The structure of the universe is not islands of matter in a sea of nothing. It is a web of dark matter filaments, with the galaxies acting as the bioluminescent nodes where the filaments intersect. But this dark master does not just hold us, it torments us. The relationship between the visible disk and the dark halo is not a peaceful marriage. It is a dynamic, sometimes violent interaction. The disk of the Milky Way is made of normal matter, gas, dust, stars, which can cool down, collide, and collapse. It is fragile. It reacts to pressure. The dark matter halo, on the other hand, is diffuse and collisionless. It forms a lopsided triaxial trap. Theoretical models suggest that the dark matter halo is not a perfect sphere, but slightly squashed, like a rugby ball. This creates a gravitational unevenness. As the delicate disk of stars spins inside this lopsided dark cage, it gets torqued. It gets pulled unevenly. The invisible scaffolding is not perfectly aligned with the floors of the building, and this misalignment causes stress fractures in the very foundation of the galaxy. We used to think the Milky Way was a perfect, flat, serene disk of geometry. But now that we understand the titanic forces of the dark halo pressing down on us, and the interactions with falling satellite galaxies, we are realizing that our disk is not flat at all. It is broken. It is bent. It is screaming under the pressure. The static map is gone. We must now look at the shape of the pane itself. If you could shrink the Milky Way down to the size of a dinner plate and hold it in your hands edge on, you would immediately notice that something is terribly wrong with the craftsmanship. The quintessential image of a galaxy is a flat, perfect plane, a celestial spinning record where all stars orbit in lockstep on a level field. This is the geometry we assume when we map the night sky. We assume a galactic plane that acts as a true north for the universe. But once again, the universe refuses to conform to our desire for symmetry. The Milky Way is not flat. It is broken. It is warped. It is twisted into an S shape. like a vinyl record left on the dashboard of a car in the scorching summer heat. Recent 3D maps generated by the Gaia data have revealed the extent of this structural deformity in excruciating detail. As you move away from the Sun and travel toward the outer edges of the disk, the stars do not stay in a straight line. On one side of the galaxy, the disk curves upwards, bending thousands of light years north of the galactic plane. On the opposite side, it dips downwards, plunging thousands of light years south. This is not a subtle imperfection. It is a massive structural torsion that involves billions of stars. If you were to look at the Milky Way from the side, it would look less like a frisbee and more like a potato chip or an uncurled S. For years, astronomers knew a warp existed in the hydrogen gas clouds on the fringes, but they assumed the stars themselves were relatively stable. The new data shattered that assumption. The stars are following the gas. The entire physical structure of the galaxy is bent, but the static shape is not the most terrifying part. The terrifying part is that the warp is moving. The twist is not frozen in place. It is traveling around the galaxy. The Milky Way is precessing. It is wobbling like a dying spinning top. This precession means that the warp itself rotates around the galactic center, rippling through the disk. The speed of this ripple is staggering. The warp completes one rotation roughly every 600 to 700 million years. This might sound slow to human ears, but on a galactic timescale, it is a sprint. It is moving faster than the models predicted, faster than the static gravity of the dark matter halo should allow. This speed suggests that the warp is not just a relic of formation, but a dynamic, ongoing reaction to violence. The galaxy is not merely bent, it is vibrating. It is ringing like a bell that has just been struck by a hammer. This realization birthed the Galactic, the field of galactosismology. Just as geologists use earthquakes to understand the structure of the Earth, astronomers are now using these starquakes, ripples in the position and velocity of stars, to understand the history of our galaxy. When Gaia measured the vertical motion of millions of stars near the Sun, it found a strange pattern. The stars were not just orbiting the center, they were bobbing up and down, oscillating through the galactic plane. But they weren't doing it randomly. They were synchronized in a spiral pattern, like the shell of a snail. When plotted on a graph of position versus velocity, these stars formed a literal spiral shape. This phase spiral is a smoking gun. In physics, you only get a pattern like that when a system has been disturbed by a massive external force and is still in the process of recovering. It is the cosmic equivalent of ripples in a pond hours after a stone has been thrown in. The Milky Way is still sloshing. We are living in a disturbed system that has not yet returned to equilibrium. The tranquil night sky is actually a snapshot of a chaotic fluid dynamics crash site. So who struck the bell? Who bent the galaxy? The forensic evidence points to a repeat offender, the Sagittarius dwarf galaxy. We tend to think of the Milky Way as an isolated island, but we are actually swarmed by smaller satellite galaxies. Most are tiny and distant, but Sagittarius is a daredevil. It is a small galaxy, perhaps 10,000 times less massive than the Milky Way, but it has spent billions of years crashing through us. It doesn't just orbit around the halo, it plunges directly through the disk. It is currently tearing through the Milky Way on a polar orbit, diving up and down through the plane of our galaxy, like a needle passing through fabric. Computer simulations suggest that Sagittarius has smashed through the Milky Way's disk at least 3 times in the last 6 billion years. Each time it punches through, its gravity drags on the stars of our galaxy. It acts like a boat wake. As Sagittarius dives through, it pulls the Milky Way stars along with it, creating a vertical wave that propagates outward. Then, as it exits, the disk snaps back, creating a ripple that travels to the edge. The warp we see today, that massive S-shaped distortion, is the scar of a recent collision. We are looking at the splash pattern of a galactic impact. This changes our perception of the galaxy's stability. We are not riding on a smooth paved road. We are riding on a suspension bridge in a hurricane. The stars in the outer disk are surfing on a wave of gravity that lifts them thousands of light years out of position. This violence is the price of growth. The Milky Way is a cannibal, yes, but the food fights back. As we rip the Sagittarius galaxy apart, stripping its stars to add to our own halo, its dying act is to twist our spine. This dynamic chaos has implications for everything, including the measurement of time and the stability of stellar orbits. If the disk is warping and precessing, it means the local environment of any given star is constantly changing over hundreds of millions of years. A star might be safe in the quiet mid-plane of the galaxy one epoch, and then get swept up into the high-density warp the next. The warp also solves the mystery of the flaring disk. As we look outward, the thickness of the Milky Way increases. Near the Sun, the disk is relatively thin, but at the edges, it fluffs out, becoming thick and diffuse. This flaring is partly due to the weaker gravity at the edge, but the warp exacerbates it, churning the stars and puffing up the outer rim. We live in a galaxy that looks less like a symbol and more like a skirt twirling in a dance, flared at the edges, rippling with movement, and twisting with momentum. This architectural violence brings the scale of the universe down to a visceral level. We are not observing a static monument. We are observing a fluid in motion. The Milky Way is reacting, adapting, and vibrating. The phase spiral discovered by Gaia proves that the last major impact happened perhaps only 300 to 900 million years ago, yesterday in cosmic terms. The ripples are still fresh. But while the galaxy wobbles and twists on the grand scale, we must now zoom in. We have established that the map is bigger, the halo is heavier, and the floor is shaking. But where exactly are we in this chaotic, vibrating, warped metropolis? For decades, we told ourselves a comforting story about our address. We said we lived in a major spiral arm, a prime piece of real estate in the galactic suburbs. We were wrong about that too. We don't live in the penthouse. We live in the alleyway. For generations, humanity has suffered from a case of cosmic narcissism. We place the Earth at the center of the solar system, then the Sun at the center of the galaxy. And finally, even when we accepted we weren't the center, we insisted on giving ourselves a prestigious address. Look at the maps of the Milky Way produced in the late 20th century. They show 4 majestic, sweeping spiral arms wrapping around the core. And there, planted firmly in the middle of a thick, bright arm, was the Sun. We told ourselves we lived on the Sagittarius arm, or the local arm, implying we were part of the galaxy's main structural architecture. We convinced ourselves we were living on Broadway. But the new maps, refined by radio astronomy, and the relentless precision of Gaia, have demoted us. We do not live on a main arm. We are not part of the primary skeleton of the Milky Way. We live in the boonies. We are residents of the Orion Spur. The Milky Way's true structure is dominated by four major density waves: the Perseus, Scutum Centaurus, Norma, and Sagittarius arms. These are the galactic highways, massive traffic jams of gas and stars where density is high and star formation is violent. But we are not in any of them. The solar system is drifting in a fragmented bridge of gas and dust, located between two of these giants. We are sandwiched between the Sagittarius arm, in toward the galactic center, and the Perseus arm, out toward the rim. The Orion spur is a substructure, a diagonal splinter of matter that connects the two main arms like a fragile causeway spanning a dark canyon. If the main arms are the steel girders of the skyscraper, the Orion spur is a piece of scaffolding hanging off the side. This realization changes the context of our existence. Spiral arms are not permanent structures made of the same stars. They are density waves. Think of them like traffic jams on a highway. The cars, stars, move into the jam, slow down, and then move out of it. But the jam itself stays. Being inside a main arm is dangerous. It is crowded. It is chaotic. It is filled with massive, short-lived stars that explode as supernovae with terrifying frequency. If Earth were located deep inside the Scutum Centaurus arm, our night sky would be dazzlingly bright, but our biosphere would likely be sterilized by high-energy radiation from nearby stellar deaths. By resigning in the Orion spur, we are living in the inter-arm quiet zone. We are in the galactic countryside. The density of stars here is significantly lower than in the main arms. This isolation has likely been the key to our survival. We are close enough to the action to have the heavy elements needed to build planets: iron, silicon, oxygen, but far enough away to avoid getting fried by the neighbors. We are in a galactic Goldilocks zone, not just in distance from the core, but in structural placement. We are hiding in the alleyway while the main streets burn. However, recent studies suggest this alleyway is more complex than a simple bridge. We are learning that the Orion spur might be part of a larger, feathery structure of inter-arm filaments. Galaxies like ours are not perfect spirals. They are messy. They have feathers, spurs, and branches that jut out into the voids. The Sun is currently drifting through one of these transient feathers. This structure is not stable. Over hundreds of millions of years, the Orion spur will likely shear apart, dissipate, or merge with one of the main arms. Our address is temporary. This demotion in status also highlights how difficult it is to map our surroundings. Because we are inside this messy spur, our view of the major arms is blocked. We have to peer through the dust of our own local bridge to see the Perseus arm behind us. It's like trying to see the horizon while standing in a thicket of bamboo. We thought the bamboo was the forest. Now we know it's just our little patch. The scale of the Orion spur is laughable compared to the galaxy itself. It is roughly 10,000 light-years long and 3,000 light-years wide. To us, that is an abyss. To the Milky Way, it is a rounding error, a minor defect in the spiral pattern. We are effectively traveling on a raft of debris, drifting between the leviathans. But as we zoom in further, the story gets even stranger. We aren't just floating in a spur. We are floating inside a hole within that spur. The environment immediately surrounding the Sun is not normal interstellar space. We are traveling through a crime scene. If you could stick a sensor out the window of a spaceship traveling through the average interstellar medium of the galaxy, you would detect a tenuous soup of hydrogen atoms. It is a near vacuum by Earth standards, containing roughly 1 atom per cubic centimeter. That is the baseline atmosphere of the galactic disk. But the space immediately surrounding the Sun is not average. It is freakishly, disturbingly empty. The density of the gas we are currently traveling through is 10 times lower than the galactic average, about 0.05 atoms per cubic centimeter. We are not swimming in the cosmic ocean. We are flying through a massive air pocket. This is the local bubble. For decades, this anomaly puzzled astronomers. Why is our neighborhood so barren? Why is the gas so hot and diffuse? The answer is violent. We are traveling through the interior of a cosmic blast furnace. We are drifting through the expanded cavity left behind by a chain reaction of supernovae that detonated roughly 14 million years ago. Picture the scene. 14 million years in the past. The Sun was far away from its current location, orbiting elsewhere in the galaxy. In this region of the Orion Spur, a massive cluster of young, hot stars was living fast and dying young. Over a period of a few million years, about 15 of these massive stars exploded one after another. This wasn't a single pop, it was an artillery barrage. The combined energy of these supernovae acted like a snowplow. The shock waves slammed into the surrounding gas and pushed it outward in all directions, sweeping the area clean. They carved out a cavity in the interstellar medium, a superheated sphere of low-density gas that is now 1,000 light-years wide. That is the local bubble. The void we live in is actually the inside of an explosion that has been expanding for epochs. The most shocking revelation came in 2022, when astronomers analyzed the positions and motions of all the young star-forming regions near Earth. The molecular clouds like Taurus, Ophiuchus, and Corona Australis. They found that every single one of these star nurseries lies exactly on the surface of the local bubble. They are not scattered randomly. They form a perfect shell around us. This confirms a terrifying mechanism of creation. The death of the old stars birthed the new ones. As the supernovae's shock waves expanded, they didn't just clear the space. They bulldozed the gas into a dense, expanding wall. This compression triggered the collapse of the gas, igniting new stars. Every young star we see in our sky is a child of that ancient catastrophe. The local bubble is not just a hole. It is a manufacturing engine. But here is the twist. The Sun does not belong here. We are intruders. We did not form in this bubble. We are just passing through. Calculations of the Sun's galactic orbit show that we entered the local bubble about 5 million years ago. We drifted into the blast zone long after the explosions went silent. We are currently located right near the center of this cavity, enjoying a momentary clear patch in the fog of the galaxy. It is a stroke of observational luck. Because the gas inside the bubble is so thin, it allows us to see out into the deeper universe with less interference than if we were stuck in a dense cloud. The clarity of our night sky is a direct result of this ancient violence. But this bubble is just one of many. The interstellar medium is like a block of Swiss cheese, riddled with these holes blown by dying clusters. We are adjacent to another massive cavity called the Lupi superbubble. The thin walls between these bubbles are the only places where matter is dense enough to create anything new. We are traveling through a structure defined by death, protected by the emptiness, watching the fireworks on the walls of our cage. However, as empty and serene as our local bubble seems, it is a tranquil garden compared to the monster that lurks at the true heart of the galaxy. We have explored the halo, the disk, and our local spur. Now, we must journey 26,000 light-years inward to the place where physics begins to scream. We must now leave the relative tranquility of our hollowed-out bubble and travel 26,000 light-years inward. We are heading into the zone of avoidance, past the thick dust lanes of the Great Rift, to the region that dictates the gravitational destiny of the galaxy. If the Orion Spur is the quiet countryside, the galactic center is not just a bustling metropolis. It is a nuclear mosh pit. It is a region of space so fundamentally hostile, so crowded, and so energetic that it defies the serene logic of the night sky we see from Earth. To understand the difference, look at the sky tonight. In our neighborhood, the stellar density is roughly 0.004 stars per cubic light-year. The nearest star, Proxima Centauri, is 4 light-years away. It is a lonely existence. But if you were teleported to the central bulge, specifically the inner parsec of the galaxy, that density skyrockets by a factor of 10 million. There, you would find millions of stars packed into the space between the Sun and our nearest neighbor. If Earth orbited a star in the core, there would be no night. The sky would be a blazing canopy of starlight, bright enough to read a book by 24 hours a day. The cosmic background radiation would be deafening. The sheer proximity of these stars means they interact violently. They strip atmospheres off planets. They perturb comets into bombardment trajectories. They bathe the region in sterilizing X-rays and ultraviolet radiation. Life as we know it is likely impossible there. For decades, we thought this central bulge was a simple sphere of old red stars, a ball of yarn in the center of the disk. But infrared surveys, penetrating the veil of dust, have revealed that the Milky Way has a structural backbone. We are a barred spiral galaxy. The core is dominated by a massive, peanut-shaped bar of stars, roughly 27,000 light-years long, rotating as a rigid unit. This bar acts like a cosmic blender, churning the gas and funneling it inward, feeding the beast that waits in the exact geometric center. And there, hiding behind the curtain of 10 billion suns, sits Sagittarius A. For a long time, Sagittarius A was just a mysterious radio signal, a loud hiss coming from the constellation Sagittarius. We knew something was there, something compact and bright in the radio spectrum, but we couldn't see it. It wasn't until astronomers spent decades tracking the motion of individual stars in the absolute center, the famous S-stars, that the terrifying truth was mathematically locked down. They watched stars like S2 whip around an invisible point in space at speeds that defy comprehension. S2 reaches velocities of 16 million miles per hour, 25 million km/s, as it swings around the hairpin turn of its orbit. There is only one object in the universe small enough to be invisible, yet heavy enough to swing a star at 3% of the speed of light: a supermassive black hole. Sagittarius A is a monster containing the mass of 4.3 million suns, crushed into a volume smaller than the orbit of Mercury. It is a tear in the fabric of space-time. It is the anchor around which the entire galaxy pivots. While it is currently quiet, meaning it is not actively consuming massive amounts of matter like a quasar, it is not asleep. It flickers. Every day, it shreds asteroids, gas clouds, and magnetic loops, sending out flares of X-rays that our space telescopes detect as the heartbeat of the void. The relationship between the galaxy and this black hole is the deepest mystery in astrophysics. We used to think the black hole was just a parasite, growing fat on the galaxy. Now we know it is a symbiotic ruler. The mass of the central bulge and the mass of the black hole are tightly correlated. They grew together. This implies a feedback loop. When Sagittarius A feeds, it burps. It ejects massive jets of energy and wind that scour the galaxy. pushing gas away and stopping the formation of new stars. It acts as a thermostat. If the galaxy makes too many stars, the black hole wakes up and shuts the factory down. We can see the scars of its last meal. Extending 25,000 light-years above and below the galactic plane are the Fermi bubbles, colossal balloons of gamma-ray emitting gas. These are the exhaust plumes from a titanic eruption that occurred a few million years ago, likely when Sagittarius A swallowed a large cloud of gas or a hapless star. The energy released in that event rivals the energy of millions of supernovae. The explosion was so powerful it punched out of the galactic disk and expanded into the halo. This proves that our quiet black hole has a temper. It is a dormant volcano, but the most mind-bending discovery at the center is the warp speed nature of reality there. In the vicinity of Sagittarius A, gravity is so intense that time itself slows down. The light from the S-stars is stretched by the gravitational well, a phenomenon called gravitational redshift. We have physically measured general relativity operating in the wild. We are not just looking at a heavy object. We are looking at a region where the rules of Euclidean geometry collapse. And yet, despite its terrifying power, Sagittarius A is tiny. If the Milky Way were the size of Earth, the supermassive black hole would be the size of a pinhead. That pinhead dictates the orbital mechanics of the entire structure. It is the dark heart that pumps the blood of the galaxy. But while we stare into the abyss of the center, a threat of a different kind is approaching from the outside. We have looked at the size, the halo, the warp, and the core. Now we must look at the future. Because the expanded size of the Milky Way, which we discussed in the beginning, has a catastrophic consequence for our timeline. The collision is not coming. It is here. The most dramatic event in the future of our solar system is a lie. Every astronomy documentary tells the same story. In approximately 4.5 billion years, the Andromeda galaxy, M31, will slam into the Milky Way. It is presented as a distant apocalypse, a slow-motion car crash that belongs to an era so far removed from the present that it feels mythical. We comfort ourselves with the timeline. We tell ourselves that for now, we are safe, separated from our colossal neighbor by 2.5 million light-years of clean, empty vacuum. We look at Andromeda in the telescope, a fuzzy smudge of light, and it feels like looking at a distant ship on the horizon. But based on the new maps of our halo and the data we have just unpacked, that timeline is wrong. The collision is not going to happen in the future. In the terms that matter structurally, it has already begun. The headline Andromeda collision in 4 billion years refers only to the moment the stars of the two galaxies begin to mix. It refers to the moment the visible disks crash. But as we have established, the visible disk is tiny compared to the true body of the galaxy. If the Milky Way is 2 million light-years wide, and Andromeda, which is physically larger and more massive, has a halo extending even further, the math becomes claustrophobic. In 2020, the Hubble Space Telescope conducted a landmark survey known as Project Amiga, absorption map of ionized gas in Andromeda. This study didn't look at the stars of Andromeda. It looked at the invisible gas surrounding it. By measuring how the light from distant quasars was filtered as it passed near Andromeda, scientists were able to map the extent of its halo. The results were staggering. Andromeda's gaseous halo extends 1.3 million light-years in our direction, and in some regions up to 2 million light-years. Now, combine that with our own halo. Andromeda reaches 1.3 million light-years toward us. We reach 1 million light-years toward them. The distance between the cores is 2.5 million light-years. There is no gap. The math is absolute. The outer atmospheres of the two galaxies are not just touching. They are overlapping. We are already inside Andromeda. If your eyes could see the tenuous, ionized plasma of the halos, if you could see the invisible universe, the night sky would look terrifying. Andromeda would not be a small smudge. It would be a colossal, glowing sphere dominating half the celestial dome, its outer layers crashing against the outer layers of our own galaxy. We are currently in the early stages of a high-altitude atmospheric merger. The gas clouds are already mingling. The pressure fronts are already interacting. The gravitational handshake has been made. We are no longer two independent island universes. We are a binary system in the process of becoming a single entity. This changes the narrative of our isolation. We tend to think of the Milky Way as a sovereign state, but in reality, we are already experiencing the tidal friction of the merger. This interaction is subtle for now, mostly restricting the supply of fresh gas falling into both galaxies, but it seals our fate. Gravity has won. There is no escape velocity. There is no turning back. We are falling. The physics of this merger, however, is counterintuitive. When we say collision, we imagine celestial bodies smashing together like billiard balls. But galaxies are mostly empty space. The distance between individual stars is so vast that when the disks finally pass through each other billions of years from now, the odds of two stars physically colliding are practically zero. The sun will not hit another star. The Earth will not be smashed by a rogue planet. Instead, the violence will be gravitational. The precise orbital clockwork we discussed, the flat disk, the spiral arms, the rhythmic pulse of the galaxy, will be shredded. The beautiful spiral structure of the Milky Way will be destroyed forever. As the massive cores of the two galaxies swing past each other, the gravity will whip stars out of their orbits. Some will be flung into the intergalactic void, doomed to wander alone in the dark. Others, likely including our Sun, will be tossed into new chaotic orbits. Simulations suggest that our solar system will likely be thrown outward. We will be exiled from the Orion Spur and flung into the high suburbs of the new combined supergalaxy. We might end up much further from the galactic core than we are now, watching the merger unfold from a safe distance. Or there is a small statistical chance we could be traded. The Sun could be captured by Andromeda's gravity during a close pass, making us immigrants in a new galaxy before the two finally merge. The endgame is Milkomeda. Over the next few billion years, the two spirals will dance, pass through each other, stretch out into long tidal tails, and fall back together. The gas clouds will collide, unlike the stars, triggering a frantic burst of star formation that will light up the sky. Then, the chaos will settle. The spirals will be gone. The rotation will stop. The two supermassive black holes, Sagittarius A and Andromeda's P2, will spiral inward and merge, releasing a pulse of gravitational waves that will ring the entire universe. The result will be a giant elliptical galaxy, a massive red dead blob of old stars, shaped like a rugby ball, with no spiral arms and no gas left to make new suns. That is our final form. We are currently living in the brief, beautiful spiral era of our local history. We are enjoying the structure before the demolition crew arrives. But even this titanic merger, this creation of a supergalaxy that contains over 1 trillion stars, is insignificant when you zoom out one last time. We have expanded our view from the solar system to the spur, to the disk, to the halo, and to the local group merger. But there is one final layer to this map. Even Milky is just a speck of dust caught in a much larger river. We are not just falling into Andromeda. We are both being dragged across the universe by something else. Something so big we couldn't see it until we mapped the motion of 100,000 galaxies. We are flowing. If you think the collision with Andromeda is the biggest thing happening to us, you're not thinking big enough. We have spent this entire journey scaling up, from the Earth to the solar system, to the Orion Spur, to the galaxy, to the halo, and finally to the local group. But even the local group, that binary dance of the Milky Way and Andromeda, is merely a single molecule of water in a rushing river that spans hundreds of millions of light years. We are not static. We are not floating aimlessly. We are being pulled. For decades, astronomers noticed something disturbing about the motion of our galaxy. If you subtract the rotation of the Earth, the orbit around the Sun, and the orbit around the galactic center, there is a residual velocity left over. The entire Milky Way, along with Andromeda and all our small satellite neighbors, is hurtling through the universe at a staggering speed of 1.3 million miles per hour, 600 kilometers per second, relative to the cosmic background radiation. This is not random drift. It is a targeted sprint. Something colossal is dragging us. Something so massive that it treats entire galaxies like dust motes caught in a vacuum cleaner. We call this mystery the Great Attractor. Located roughly 150 to 250 million light years away from us, in the direction of the constellations Hydra and Centaurus, lies a gravitational anomaly of terrifying proportions. It is a region of space containing the mass equivalent of tens of thousands of galaxies, concentrated in a way that warps the flow of the entire local universe. But for the longest time, we couldn't see what it was. By a cruel cosmic joke, the Great Attractor lies directly behind the zone of avoidance, that same dusty plane of our own Milky Way that blocked our view of the galactic edge. We could feel the tug, but we couldn't see the hand. It wasn't until 2014 that a team of astronomers led by Brent Tully at the University of Hawaii redefined our place in this chaos. They stopped looking at where galaxies were and started looking at where they were going. They mapped the peculiar velocities of 8,000 galaxies, tracing their movement flows like dye dropped into a stream. What they found changed the map of the universe forever. They discovered that we are part of a localized gravitational watershed. Just as rainwater falling on a continent divides into different basins, some flowing to the Pacific, some to the Atlantic, gravity divides the universe into basins of attraction. Boundaries exist in the cosmos where galaxies on one side flow toward one center of gravity, and galaxies on the other side flow elsewhere. Tully's team traced the boundaries of our flow and realized that the Virgo Supercluster, which we used to think was our home structure, is merely a small appendage of something far greater. They named this true giant Laniakea. In the Hawaiian language, Laniakea means immeasurable heaven. It is a fitting name for a structure that spans 520 million light years. It contains 100,000 large galaxies and the mass of 100 quadrillion suns. Laniakea is not a solid object. It is a web. It is a collection of filaments, sheets and voids, all interconnected by gravity, all flowing toward a singular point. The Milky Way is located on the far outskirts of this supercluster, dangling near the edge of the watershed. We are effectively living in the remote foothills of a mountain range, and the river of gravity is carrying us down toward the valley floor. The valley is the Great Attractor. It is the gravitational heart of Laniakea. It is the drain at the bottom of the basin. Every galaxy in our supercluster, including us, is slowly falling toward it. But the map gets even stranger. While the Great Attractor pulls us from the front, we are being pushed from behind. In 2017, astronomers discovered that the region of space directly opposite the Great Attractor is remarkably empty. It is a void so devoid of galaxies that it effectively exerts a repulsive force. In gravity, emptiness acts like a negative mass relative to the dense regions. This void is called the dipole repeller. It is pushing the local group away from it, adding speed to our fall. We are caught in a cosmic push-pull dynamic, fleeing the void and rushing toward the cluster. This flow reveals the true texture of the cosmos. On this scale, the universe looks like biological tissue. It looks like the neural network of a brain. The galaxies are merely points of light, stringing along dark matter filaments that stretch for hundreds of millions of light years. The voids are the empty spaces between the neurons. Laniakea is just one cell in this cosmic brain. It borders other monsters, the Shapley Supercluster, the Perseus Pisces Supercluster, the Coma Supercluster. These are the continents of the universe. The realization of Laniakea humbles the Milky Way in a way that simple size comparisons cannot. We just spent this entire journey discovering that our galaxy is a 2 million light-year giant, a monster of dark matter and warped stars. But inside Laniakea, the Milky Way is microscopic. The entire local group, us, Andromeda, and the collision that will merge us, is barely a pixel on the map of the supercluster. Our 4 billion-year drama with Andromeda is just a local fender bender happening in the back seat of a car that is speeding down the highway at 1 million miles an hour. Does this flow end? Will we ever reach the Great Attractor? No. This is the final tragedy of cosmic scale. The universe is expanding. Dark energy is stretching the space between the superclusters faster than we can fall through it. While gravity holds the local group together, and perhaps holds Laniakea together loosely, the distant structures are accelerating away from us. The Great Attractor is pulling us, but the space between us and it is growing. We are running on a treadmill. We will never reach the center. We are destined to float in this gravitational river, flowing toward a horizon that recedes forever. This is the context of our existence. We live on a planet, orbiting a star, inside a spur, inside a galaxy, inside a halo, inside a merging binary system, inside a supercluster, flowing toward a phantom attractor in an expanding void. The layers of containment are dizzying. Every time we think we have found the edge, we find another container. Every time we think we are big, we find something that makes us small. But there is one final shift in perspective we must make. We have looked out. We have measured the light years, the masses, and the velocities. We have confronted the terrifying indifference of the physical universe. Now, we must look in. We must ask the question that naturally arises when a human mind confronts infinite scale. If we are this small, if we are dust on dust in a universe of monsters, what is the point? Why does knowing this matter? The answer is not in the stars. It is in the observer. We began this journey with a simple question about a number. We asked if the map was wrong. We discovered that it was not just the map that was wrong. It was our entire conception of scale. We have journeyed from the safety of our small blue world through the hollowed out shell of the local bubble, across the warped and twisted disk of the Milky Way, into the invisible tyranny of the dark matter halo, and finally out into the rushing gravitational currents of Laniakea. We have seen that we live in a violent, dynamic, merging, and rushing universe that operates on scales so vast they threaten to crush the human spirit. It is easy to look at these numbers: 2 million light years, 4 million solar masses, 500 million light years, and feel a sense of crushing nihilism. In the face of a galaxy that is mostly dark matter and a supercluster that pulls us like flotsam in a drain, a human life seems less than microscopic. It seems like a rounding error. If the Milky Way is a titan, and Andromeda is a monster, and Laniakea is a god, then what are we? We are dust on a rock, orbiting a spark, drifting in the dark. But to stop there is to miss the most important discovery of all. Consider this: the galaxy does not know it is 2 million light years wide. The dark matter halo does not know it is holding the stars together. Sagittarius A does not know it is warping time. The Great Attractor does not know it is pulling us. These titanic structures possess mass, energy, and gravity, but they do not possess awareness. They are blind giants. You do. You are the one who measured the distance. You are the one who calculated the mass. You are the one who realized the collision is inevitable. The fact that a biological organism evolved on a wet rock in the Orion Spur, effectively made of processed light, sunlight, and carbon, can look up at the sky and reconstruct the history of 13 billion years is the most shocking fact in the universe. The scale of the cosmos is matched only by the scale of the mind required to comprehend it. We are not merely inhabitants of the Milky Way. We are its consciousness. We are the mechanism by which the universe understands itself. When you look at the band of the Milky Way in the night sky, you are not looking at a separate object. You are the galaxy looking at itself in the mirror. The iron in your blood was forged in the supernovae of the high-density arms. The calcium in your bones was brewed in the hearts of dying stars. The hydrogen in the water you drink is as old as the Big Bang. You are not in the universe. You are the universe, briefly awakened to a state of wonder. This new map, this 2 million light-year behemoth, does not make us smaller. It makes the territory we have intellectually conquered larger. Every time we push the boundary of the edge further out, we are expanding the domain of human knowledge. We used to think the world ended at the horizon. Then we thought it ended at the atmosphere. Then the solar system. Then the visible disk. Now we know the halo touches Andromeda. We keep pushing the walls back. The discovery that the Milky Way is twice as large, more violent, and inextricably linked to its neighbors is not a scary story. It is a story of connection. It means we are not isolated on a lonely island. We are part of a grand interlocking system that stretches from the atoms in your DNA to the filaments of the cosmic web. We are small in space, yes, but we are giants in time. We carry the history of the galaxy in our bodies, and we carry the future of the galaxy in our minds. So the next time you look up at the night sky, do not feel small. Feel the warp of the disk. Feel the rush of the flow toward Laniakea. Feel the invisible embrace of the dark matter halo. And remember that while the universe is vast, it is also knowable. And as long as we keep asking questions, as long as we keep building machines like Gaia to scan the dark, and as long as we keep rewriting the maps, we are not lost. We are simply exploring our home. The Milky Way is bigger than we thought, but so are we. If you want to keep exploring the impossible reality of our universe, hit that like button and subscribe. The map is still being drawn, and the journey is far from over. Thank you for watching.